Sequences and series. Consider the following example. Suppose you are asked to find the number of ancestors, that is, parents, grandparents, great-grandparents, etc., that a person might have over 300 years by assuming that there is a generation gap of 30 years. Hence, the total number of generations is equal to 300 by 30, which is 10. The number of persons' ancestors for the first, second, third, etc. up to 10th generations are 2, 2 power 2, 2 power 3, 2 power 4, etc. up to 2 power 10. These numbers form a sequence. Now, the terms of the sequence are A1 is equal to 2, A2 is equal to 4, A3 is equal to 8, etc. and A10 is equals to 1024. The nth term of the sequence is called general term of the sequence. Finite and infinite sequence. A sequence containing finite number of terms is called a finite sequence, and a sequence containing infinite number of terms is called an infinite sequence. Consider a sequence of even natural numbers. Consider a sequence of even natural numbers. Here, the first term is 2, second term 4, third term 6, fourth term 8, etc. 10th term will be 20, 100th term is 200, etc. Hence, we can write nth term, that is general term of this sequence as 2n. Similarly, we can write the general term of odd natural numbers as 2n minus 1, where n is a natural number. Therefore, a sequence can be regarded as a function whose domain is the set of natural numbers or some subsets of it of the type 1, 2, 3, etc. up to k. Sometimes we use the functional notation a of n for an. Series. Let a1, a2, a3, etc. an be a given sequence. Then the expression a1 plus a2 plus a3 plus etc. plus an plus etc. is called the series associated with a given sequence. The series is finite or infinite according as the given sequence is finite or infinite. The series a1 plus a2 plus a3 plus etc. up to an can be abbreviated as sigma k is equals to 1 to n ak. N